Hello, I'm Ben Young, Field CTO here for Veeam Software based out of the APJ region. I'm going to talk to you about Veeam Data Cloud, our global backup as a service platform powering many workloads from M365 to Salesforce and also protecting things like Azure, all within an as a service platform. Two initiatives we're working on in this space in particular that I want to talk to you here about today is AI-based data discovery and also threat detection. So let's kick things off. We'll start with AI-powered hybrid search capabilities, and I emphasize the hybrid thing here, and we'll talk about that in a second. So what did we set out to build? Well, quite simply, we wanted the smartest search in the market. We wanted you to be able to use natural language. We didn't want you to have to use complex queries to find the information that's within your backups so that you can either recover them, download them, do whatever you need to do with the information that's held in your backups. The next is the hybrid piece. We really wanted this to be keyword based, so more of that traditional search where we're looking for exact matches to names, purchase order numbers, project names, etc. And we wanted to blend it with semantic search. This is kind of where the AI piece comes in. We want you to understand the query. We want you to find related terms and meanings of things, to really combine these two types of searches together to give you the best results, the most accurate results, and also very fast. And when it comes to filtering, traditional search filtering or just traditional data in general, we might have filters such as the ability to select, a certain query, which might be our keyword based, then we'd filter down by to or from, maybe a date range, that sort of thing. We wanted this to blend into that natural language query. So you didn't have anything complex. You just describe what you're looking for and how you want to find it. We'll do the rest within our hybrid search engine. And of course, it's all well and good finding the results, but we are ultimately a backup as a service platform. People want to be able to recover this data, so we wanted all of these search results to have actionable actions that can come out the other side of this, be able to recover that data. And so that was absolutely critical to what we've designed. So we look at a real-world example of what we're talking about here. Let's say take this query, emails with attachments from the last 2 months related to marine power generation. The first thing we do before we go search any data is actually pass this off to a private Azure OpenAI instance. And we start interrogating this query with some kind of advanced logic and some code we've written here. We want to determine a couple of things. We want to extract from this prompt, what are the filters? And the next thing is we need to know what is the user looking for. And so when we break this query down itself, you'll see that emails with attachments from the last 2 months related to marine power generation. So the two things in yellow there are our filters. It's a date range and it's also some other metadata that we store as part of our search index, things like does the email have attachments? And marine power generation is ultimately the query. So as the backups are processing, as new objects come into your backups, we also put them through this data discovery service and we actually embed them. We extract the keywords, but we embed the meaning of those points. We understand it with an embedding model, some AI systems. And we plot them in a vector space. This is a 2D representation of that. But you can imagine here's some topics, in someone's mailbox, for example. That query, that marine power generation, we run that through that same process and we actually embed that. That gives us a bunch of numbers as well, and we can plot that in that same vector space. And that kind of puts it, say, somewhere in the middle here. We can then draw a kind of a radius around this and say how many queries or how close to this point do we want to get, kind of represented by this orange circle here. We then apply those magic filters we're talking about to exclude, say, this dot here, which might be older than 2 months old, so we can exclude that from the results, and then largely we get these results back. And you can see here it's kind of returned, marine energy systems, which isn't an exact match for our query, but marine certainly was, so that would be a good example of maybe matching on a keyword, but energy systems is definitely related to power generation. And other terms here, like offshore electrical production and ocean power turbines, are very much related to that original query, but they're not using any of those same keywords. And that's kind of that semantic understanding of what that user was looking for. This is obviously a very simplified example. So this is what it looks like within Veeam Data Cloud. You can see here we've done a search here with attachments in the last 3 months. So that's kind of just a filtering query. It doesn't always need to actually search for keywords or kind of semantic understanding. We can just use it to just filter. But the same box is used for semantic query, just like we showed you in that example. Once you've got those items, you'll be able to select single or multi, and this is actionable insights. So then what happens here is I can now just run through the normal workflow within Veeam Data Cloud. That might be restoring it back to the original location, downloading it, whatever we need to do. So that's what we're talking about from a hybrid search capabilities. If you want to learn a lot more about it, my colleague Zach is also talking at Ignite in person, so go see his session on how they've built this engine in particular at scale on Microsoft Azure. So we're going to change gears a little bit, and we're going to start talking about ransomware and malware capabilities that we're bringing into Veeam Data Cloud, in particular ransomware. So you can see here we're building up a new threat center. We're using some signals we're pulling from Microsoft 365, but then a whole heap of proprietary models and machine learning systems that we're embedding into our backup engine here to generate this threat center. Any threats that we detect, we'll push up here. We'll talk a little bit more about that happens. You can then view each of those threats, see where they were, was it on a SharePoint list, what path were they in, and then you can go and investigate and then close the threat. So when we look around like what the overview is here, you can see we're running dual detection engines. We want to make sure that we're as accurate as possible when we're trying to detect these type of events. And so we've got two profiles, and these run simultaneously to not slow down backup operations. We've got what we call the fast backup profile. This is often the easier one to detect. It's sudden, high volume encryption activity, very aggressively going after, say, a SharePoint environment, etc. That's going to have an immediate impact. So we can detect that with our fast profile. But we know a lot of these threat groups are actually a bit more cunning. They're trying to evade detection. They're trying to slowly kind of work its way through and start causing impact within your environment. And so we're using also this kind of extended attack profile to kind of detect these attacks that are trying to avoid detection. Critically, though, all of this detection engines also preserve privacy. So we're only using metadata and file headers. We're not actually looking at the content of the files themselves, and this really helps with privacy and compliance. Also, the way that it's distributed means it gets processed in the country that your backups are. It's a distributed system. It's not necessarily a singular system that we've deployed. So wherever Veeam Data Cloud is, it's going to be enabled. It's also personalized. So it's not a global view of what normal looks like in your environment. It's actually based on a per user or a per site basis. So all the signals that we're learning about this environment, certainly in that extended attack profile, we're starting to build up this model, this baseline of what kind of normal looks like. And then when things deviate, we can spot it and attack it and alert you. So when we talk about multi-dimensional analysis, this is what we're doing here. We don't want a single dimension. We don't want to just look at one dimension and say, hey, that looked out of the normal. We want to take multiple dimensions to really, again, make it as accurate as possible, reduce false positives. So the first thing we're looking at is suspicious entropy. So entropy is the randomness of a file. We're also looking at extension verification. So, for example, we know what a JPEG looks like in its file headers, its bytes. If we see a JPEG that doesn't look like a JPEG, that could indicate, a strong ransomware indicator. Something's happened inside that file. That's another one of the dimensions that we use. The other, of course, is just generally what's happening in your environment. We're tracking the accounts of files updated, between backup sessions to detect kind of things that fall outside of that normal scope. And ultimately, this feeds into, like we've talked about this, reducing of false positives, just a more accurate system for detecting potential ransomware threats. These are just some of the signals we're using. We've talked through, so unusual ratios of added in files. The blast radius is really interesting. Looking at the total scope. Is it 1% of the environment that's affected here, or is it 80%? That really helps us dial down on exactly what we're looking for. So why does this work? And fundamentally, why this works is normal backups, when they run from restore point to restore point, they form dense clusters. They look normal. They all kind of, when we plot these points together, they look normal. And so ransomware, often, when we put all these dimensions together, they form outlier patterns, and we can start breaking down these clusters and working out, hey, there's a suspicious kind of activity that's happening. And the result is really we can isolate that quickly from those large clusters of backups. And the best part is it's automatic. We don't require any training data sets to make this happen. It's on that per resource level. It's very, very efficient and allows us to run at the massive scale that we do within Veeam Data Cloud. And really the TLDR here is that it really does create, ransomware does create unusual patterns, and we can spot that through our threat detection systems. A critical part, though, is the human in the loop. We want to make sure that we have a human in the loop. We want to make sure these are reviewed before they come up to you, and that's exactly what happens. So we call it threat lifecycle management. Essentially what's happening here is they're reviewed first by Veeam. So what I mean here is any detections through either of those fast or extended profiles actually bubble up to a Veeam team. Veeam team will then look at all of the metadata associated by those attacks, and then they'll triage it for us. It first goes into an in-review state, meaning the threat is being investigated by Veeam operators. You will still see it at this state, it's just in an in-review state. Then the team will determine whether or not it ramps up to an active or a false positive. And if it goes to active, this is when you get involved. You will get an alert, you can subscribe to these alerts, which we'll talk to later, and then you can go and investigate, confirm, and then mark it as resolved or as a false positive, whatever you need to do after that has happened. So how we score things too, once all those engines run, we use basically a threat score, and we assign a score of 0 to 100. This fundamentally indicates the level of severity, as well as our confidence score, showing the reliability of this detection, and you'll see that. The blast radius is something that we're working on here, and that's what we use to determine, form part of our threat score. The other critical thing here is, let's say that there's 100 files affected in a single SharePoint site. We didn't want 100 alerts. So what we do is we aggregate all of these alerts up into one kind of threat. Say, hey, something's happened in your environment, and we say, here's where the files are, rather than you having to clear 100 alarms. Just really, it not only helps our data set size on our end, but more importantly, it also just improves the overall user experience for you. So if we kind of recap what we've just talked about here, it's all about analyzing files and behaviors within your environment that you're protecting with Veeam Data Cloud, and trying to find anomalies in that data set. We then run all of these anomalies or suspicious behaviors through our decision framework and bubble those alerts up to you through the Veeam Threat Center within Veeam Data Cloud. And then you can use the Threat Center to basically what we call structured threat querying. So you can actually query these threats based on a number of factors to really dial down exactly what you're looking for there. And then the interface itself actually allows you to update the threat status. So again, move it to resolved or a false positive. The other thing here that's really critical to note is that we have a separate role. Veeam Data Cloud is very strong in role-based access. This is a particular role that you could put users in. So you might have a whole security team dedicated to just dealing with the threat center, but maybe they can't do backup operations. And the reverse is true. You might want backup operators not to be able to touch the threat center. But of course, you can apply that role to across multiple of those different profiles as well to enable both. So that's talking about within Veeam Data Cloud, viewing that threat center. But what if you wanted to use the threats externally? This information, these signals that we're pulling from Veeam Data Cloud in another system. And this is where model context protocol can happen. It allows us to provide Veeam context for other AI-based applications. It's standards-based, so there's a lot of adoption globally for this, Copilot being one of them, and I'll show you a demo of that. Fundamentally, this has an ecosystem benefit. You can subscribe to context here. You might be using other systems via this protocol, as well as other various ecosystem benefits. We're going to be able to build richer Veeam applications as well. And the great thing is you can bring your own large language model, your own agentic system, whatever that might be. That might be for privacy or just preference purposes. But the important thing is you can use the context that we're giving you. And so this is fundamentally how it works. We've got Veeam Data Cloud. Down below is the blue data layers, all the services and all the smarts and all the algorithms that run here. And the Threat Center and other services are exposed via Model Context Protocol. And that allows us to plug in and build our own Veeam-powered apps on our own Veeam-qualified large language models within Veeam Data Cloud. But what if you wanted to build an agent that used these signals from the Veeam Threat Center inside a Copilot agent, for example? And that's where the Model Context Protocol comes in. You can connect that up via MCP and build something like a threat automation bot. And so why don't we flick across now to a Copilot agent and talk through exactly how that works. Okay, now within Copilot Studio, and what I've built here is a Veeam Threat Intel agent. So if we go into the Veeam Threat Intel agent, you're going to see a bunch of the settings. Obviously, you would normally consume this agent within Teams or wherever else you can deploy these Copilots, but I wanted to show you the decision-making process and how you can start building these things yourselves. It's got access to some external knowledge sources, such as the Microsoft security site, as well as a website that contains up-to-date information about different malware families and things, as well as a bunch of tools. So I've got it connected to Teams, as well as ServiceNow. So if we go back and we say, what does my Veeam Threat Center look like today? What's going to happen here is the agent will work out what it needs to do to fulfill my request. So you can see it's connected to Veeam Data Cloud. That's another tool that I've added to the agent over that model context protocol. And it's called Get Threats. The agent worked out that it needed to call that particular tool to pull those threat contexts out of Veeam Data Cloud and present them to Copilot. So you can see it's your Veeam Threat Center has detected active malware threats in the 𝗦𝗀𝘀𝗀𝗃 AI project team SharePoint site. In the latest backup, it's found passwords.zip. It contains the 𝗦𝗲𝘀𝘀𝗀𝗃 Trojan, 𝗦𝗲𝘀𝗀𝗀𝗀𝗃 Trojan, and 𝗬𝗲 Trojan. So not a fantastic day for us here. So what else could we do here? I might not know, for example, what 𝗦𝗲𝘀𝘀𝗀𝗃 is. So I can then say, provide me some more information about these families, their tactics and techniques. And what will happen here is I want to now enrich this with those data sources, those acknowledged sources, those security sources. Maybe Microsoft just released a new blog on a particular Trojan here. We can go get real-time data now from the web and actually start building in information and enriching the threat center signals you got from Veeam Data Cloud. So if I scroll down here now, it's actually given us a really good overview of 𝗦𝗀𝘀𝗀𝗃 Trojan family, what it does, how it uses, how it moves in our environment. And that's pretty great. And we can start keeping enriching it, keep asking questions, and it will fulfill our requests. But one common thing might be now to raise an incident. We've found some malware, we might want a ticket to track that inside our environment. And that's where something like ServiceNow might come in. So I will say we had better raise an incident for this in ServiceNow. And what will happen now is the agent's going to try and fulfill this request. It's going to look at its available tools and knowledge sources, and you can see it's picked the ServiceNow connector. An incident's been raised in the ServiceNow to track it. You can manage the malware threats, etc. So you can see it's created one in there. And if I flick across to ServiceNow, and you'll see in our incidents here, we've got these incidents that have been created here. So the other thing that we now might want to do is we might want to create a team. We might want to set up a war room. We might want to drag people from our IT teams and our security departments and start discussing this threat that we've got going on. So maybe we might want to create a channel within a team. Let's create a Teams channel to discuss this threat. Give the channel name, the incident number. So now what the agent will do is evaluate this, and it will actually start blending some of this information. It will pull out the incident number from ServiceNow. You can see it's now getting a team. This agent has been told that the incident response things go into a particular team that can be customized, or you can interact with it, but I've got it fixed. And you can see it's now created. It's going to create a team or a channel within the team called that. So I can now flick across to our window here, and if I refresh this page, then we should see that team or that channel now being created. So there you go, incident 124, and now we can start talking with our colleagues. The other thing I might want to do is send a message to that new channel, include the malware report. And now what it will do is we'll be able to pull that information we've already generated and push it into that channel that we just created there a while ago, and then it will create that message. So it's just posting our message now into that channel, and so when that's complete, we should be able to go across to Teams. And there you go, incident 1.024. Here's our malware report, been created in Teams. So all within a very simple Copilot agent, we've been able to pull that threat center information from Veeam Data Cloud, where we flag those malware threats for you. And then you have enriched that information with external data sources, created a ServiceNow incident, and created a war room with some information, all within a pretty simple process. So if we wrap things up now, we've just viewed that demo of that Copilot agent. Really wanted to highlight not only the semantic search, that hybrid search, that AI-powered search that we're building into Veeam Data Cloud to help users find information more accurately and faster with just natural language queries and really optimizing that search experience, but also really hammering home this threat capability that we're building in, which is unprecedented in the market. Now, we're using advanced detection techniques here. It's adapting, again, on that per user, per resource model that's kind of been built up so we can start detecting those anomalies that sit within there. That human in the loop factor, making sure that the Veeam team is behind all of this, making sure they're reviewing those threats before raising the alarm to active, and the way that we consolidate everything down to kind of really optimize that user experience for you. And largely it's built for scale. Azure's really helping us with this. We can, as we scale and grow the Veeam Data Cloud across the world, this is going to grow with us, which is really fantastic. So yeah, if you want to know more information, in particular around the semantic search, there's also another session that my colleague Zach is running at Ignite. You can go hear more about how himself and the rest of the team built that technology, that AI-powered search, and how we're using 𝗦𝗲𝘀𝘀𝗶cie. So make sure you check that out. Otherwise, you can find us at veeam.com.